Now, math and especially geometry is a lot about vocabulary, and I do a lot of vocabulary in my other classes. You really can't communicate without the vocabulary. If you want to tell me that you want to do something, you have to say, you're talking about a segment or you're talking about an array. So one of the questions that came up in my other class, and I haven't heard it here today, but my guess is if one of you has this question, there's at least another person, and maybe I wasn't clear about that. We drew a picture of array. I don't know if it was in the homework or the lesson, I don't remember. And it was A, B, C. I love it when I do that. I'm already thinking C. Now, if the 3 points lie on that line or on that ray, what's the word we use for that? It starts with a C. Collinear. Okay? So you've got to know the vocabulary, because we keep hitting you with more and more vocabulary every day. Okay, and if you're using iPads, we'll have to talk about iPad rules. I see iPads up, which is good, which means you should be on this lesson. If I see something other than that, I may take it away and make you go back to paper, pencil, and I won't provide notes. You'll just have to do them. Okay? Sorry if it seems like I'm a little strict about it, but what happens is you don't pay attention. So they're collinear. So how do you name this ray? You always start with the endpoint, A, and you can go to any point on that ray. So a lot of you said, well, it's ray AC, which is fine. Right. But in the other class, somebody said, well, how can you call this ray AB? You can't, because a ray goes forever. So you're starting at A, and you're going to go through B. You will pass through C. So that's perfectly okay. And the student was then talking about segment AB. That's a different thing. Segment AB is only this little piece right here. So this little part with the arrow is critical. That's important. So you can't just omit it. Now, math is a lot easier than some languages. Do we have any Chinese students here? One? Just one Chinese student? Usually I have more than that. And how a word may be spelled, I don't know how you would say that in Chinese because you have characters. But they probably also have English spelling. It's like they do in Arabic. Okay, so there's the Arabic. And I believe that this is the letter A. And you put a little diamond up here, and that means something. Without the diamond, it doesn't mean anything. Put the diamond down here, and I haven't studied my alphabet that well, so that may not even be a letter. It means something entirely different. And how you say the word takes on different meaning. Is that not true in Chinese? It may be the same word, but how you inflect it? And I can never say, how do you say hello in Chinese? And actually, my Chinese student would probably say ni hao as opposed to ni hao. And I thought I was doing it just like her. I mean, I thought I was doing it just like her, and I'm still wrong. Whatever I said was wrong. So that all matters. So be thankful we're not in Chinese, or be thankful we're not in Arabic, because how you write things makes a difference, and how you say it makes a difference. It's the same in math. If I have that little arrow there, that's not the same as that little segment there. And some of you may say, well, that's pretty particular. Yeah, it is. And if you're in a foreign language where it's particular like that, you're going to be in trouble. So you got to be able to do that. In my algebra classes last year, some of the students wanted to ignore the negative signs. They just thought they were kind of a bother. But you can't ignore the negative signs. They're there. They mean something. So everything you see here means something. So we have to know the vocabulary, or we cannot talk about the geometry and what happens in the real world when we put objects together. The only way to describe this is to talk about this as a segment. I could talk about the line containing that segment. Now you know it goes up to infinity, goes all the way to the earth, and I don't know who's on the other side, but out to infinity on the other side as well. So all that makes a difference. So I like to give you the objectives. This is actually the geometry team has been writing these, which is fine. I would do it anyway. So before you leave today, this is what you should be able to do. You should be able to find overlapping segments, know that conjecture. Do you guys know what conjecture means? I'm using that word, but if you don't know what it means, you better say something. I could start speaking in Arabic, and you're going to be going, huh? It's a guess. Now, you guys had that word yesterday, I do believe. And I know Mrs. Ellis. She's the queen of geometry. So she knows. I'm sure she taught it. It's a guess. It's a hunch. How about a hunch? I like that. And don't you do that in science class? Don't you do an experiment and they say, what do you observe? What do you think is happening? What's true? It's a hunch. It's a guess. It's a conjecture. And then, of course, you have to prove it. Well, we're not going to prove this. We're just going to look at situations and say, oh, I think that's true. Okay? By the way, if you're on an iPad and you want to write in your notes on your iPad, that's fine. You use Notability, and it should be, you'll have to go to your, wherever you get your apps and download that. And once you get used to that, especially if you're a sophomore, as opposed to remarks, you're going to like it so much better. Also, if you're doing paper pencil, I forgot to mention this, in my drawer, just help yourself. I have, and maybe I'll put it in one of these boxes, I have all my markers, colored pencils, pens, because I find geometry a lot easier when I use color. But with the iPads, you should be able to do that. We're both in a learning mode on that one, by the way. And we're going to learn how to solve problems. Now, I've never called it overlapping segments. I would call it the segment addition postulate, which is something I can't prove. But that's okay, as long as we're both kind of on the same page. I have to learn the vocabulary in this course. It's going to be different than what I've done. And then these words here, we're going to be able to define, and not only define, but use these to solve some problems. Supplementary angles, complementary angles, and isosceles triangles. Raise your hand if you know of at least one of those words. At least one. You don't know any of those words? Raise your hand if you know one, at least one. I'm not asking for all. Lindsay, you don't know what any of those words are? It's possible. I'm just trying to find out. Okay. This is old stuff. You can put your hands down. So we're going to use this, and we're going to put algebra together. And honestly, it doesn't get much harder than this in terms of the algebra, which is really nice. I know I just taught quadratic algebra last hour, and they give the kids some pretty complicated equations to solve. I've never seen anything that complicated. It's going to look like what we're doing here. And I teach calculus. I've taught calculus for 20 years. Never as complicated as what I just taught in quadratic. Okay, so we're going to turn the page here, and we're going to look at this overlapping segments conjecture. There is a little mistake here in terms of how this is written, because that sentence makes no sense to me. This says if the measure or the distance from A to D has points A, B, C, and D in it, huh? It's not distance. What's happening here, and I don't know if it's just an accident, this is a segment. If segment AD, well, they should have put a segment, or they could put a line in there too, for that matter. But we're going to put a segment because there is no line. There's a line that contains those, but there's no line drawn. There, now I'm happier. If segment AD has points A, B, C, and D in that order, and then what does this mean? Is this segment AB, or is this the length of AB? It's the length. Without the bar, it's the length. So those are things you have to learn. It's only the first week of school. Learn them now, because we're going to be adding so many new words. If you wait to the end of the unit, you will be confused if you're not already. So just trust me. Learn it now. But I want to talk about the segment, and it says the length AB equals the length CD. We use these little tick marks to say that they have the same measure. You know what? I don't want to be particular about that either, but honestly, that's what you have to do. And if they have the same measure, what's another way I could write this? AB is what? Congruent to CD. It has, here's a way to remember it. I like tricks, but honestly, it's what it means. But this has that little extra bar up there, which means you're going to have a little bit of extra something in the equal. But that's just a little bit of a hint to help you remember. And if they're congruent, they have the same measure. And then they say AC is equal to BD, the length of AC. So this length here is equal to the length from B to D. Think about that. I love geometry. Why is this called logical reasoning? Because this is logical. Segment AB and CD, they are the same. They have the same length. And if I add this little segment in between here, BC, if I add that to AB, and if I add the same number to CD, but remember, AB and CD are still the same lengths, same numbers, don't you think the results are going to be the same? Does it not make sense? So in the next example, which I actually wrote on there, but let's write it down here. If AB is 7, I write it right on my diagram. In the old days, we had books. You had to copy the diagrams down, and then you had to write on your diagrams. And that was the first battle, copying the diagrams. Guess what? It's all done. I just gave you a worksheet, so you can just copy it. I mean, it's already, you don't have to copy it. Just write it in there. And now, if AB is 7, how big is CD? 7. And I'm just making up a number. If this length is 10, then wouldn't this length be the same as that length? If you don't see it in words or in symbols, put in numbers. But you know what? I don't know how big that is. So let's get rid of it. Now you can call the length of this BC, or you can be lazy like me and give it a letter name. I like to give it a letter name. What would you like to call that length? You can call it BC, but I'd rather call it, how about X? I can do BC. It's just more cumbersome to do. It's not a big deal. And there you go. What else do I know? I know that the total distance from A to D is 25. You see what I'm talking about, knowing your vocabulary? When you look at it, you see 80 is 25 centimeters. That means the distance from one end to the other end is 25. Now, we're going to be doing Marzano scoring rubrics, which means I don't care if you have the right answer. If you don't have the work to support that, you get no credit. 0, zippo. I don't care if you tell me I can do that in my head. I don't care. This is about communication. My job is to teach you, to help you when you don't understand. If you don't write anything down, even if you have the right answer, that doesn't mean you understand. I can't do my job. Remember, I'm your coach. So, I'm telling you, if we're going to practice dribbles in basketball, we better do it the right way. Or shots in golf, especially shots in golf. Sometimes you do it the wrong way, you get the right result. But I want something to work every single time. So we're going to work it every single time. So what do you think you can do with these 3 numbers? Because X is a number. I would rather see us write an equation. I'm glad you said that because I hadn't thought of it that way. Yes, you can subtract the 7s from the 25, but let's write the equation because this can be way more complicated than that. Equals, and what was the total distance? 25. Now, that tells me what my intent is. My intent is to find out what that number X is. Maybe. Better read the question. But I will find it. And I know how to do that because that's what we did last year. We took algebra. That's why you took algebra. This is a tool to help you figure that number out. The minute I make the 7s into some ugly fractions or decimals, now you can't use your process. And the minute I make this 2x minus 5, again, you're going to have some problems with your process. So let's start from the beginning with simple problems and make it easy. Now you remember from solving equations that we will combine similar terms before we try to solve. We never want to solve until we have things as simple as we can. And that may be something odd for you guys. But what's 7 and 7? 14 plus x equals 25. And I don't care if you do this by inspection or you show your work. If you show your work, you must show it correctly. If you show it incorrectly, I will mark it wrong. If you do this, minus 14, and then you say x equals 11, that's wrong. Why is it wrong? I didn't do this on the other side. Everything must be mathematically correct. Some of you are going to take calculus here. Some of you are going to take calculus in college. Some of you may never take calculus. You may take college algebra, which is really a tough class. I think it's harder than the calculus. If you don't show the right mathematical steps, you will get it wrong. So let's learn it now while you've got me. And you're in a small class, not 300. At the U of M, it's 300. If you want to go to Gustavus, McAllister, or St. Olaf, the lowest class they offer in math is calculus. You have to start there. So if you don't do pre-calc here before you leave, you're going to have to do it over the summer if you go to one of those schools. Now, the University of Minnesota and Wisconsin, they do have lower classes called college algebra, and they're tough, tough classes. And guess what? You pay for them and you don't get any college credit. It doesn't count towards graduation. But you got to take it because you're not ready for calculus if you don't take it here. My recommendation, take as much math here as you can stand. The more math you take, the better your chances of getting a job, and I don't care what it's in. It could be in newscasting. They still like people who can think logically. And that's what math is all about, thinking logically. If you're a math major, then you like to think about some other things. You like to see why things work mathematically. That's the difference. Math, and as far as we're concerned, will be a tool. And I'm going to use my algebra as a tool. So I found x is 11. And guess what? All this chit-chatting, I forgot. What am I looking for? I'm looking for the length of BC. What is the length of BC? 11. That was easy. But to get your whole score on the scoring rubric, you must have all that work. Well, then we can find BD. And BD is not so simple. Now, I know you can write the answer down. But now we're getting ready for the big assessment on this. You want to go back and study. And so what are you going to do? You're going to go back and look at your notes. At least that's what you should do. Can you do the problem again? And you don't understand why the answer is 18. Okay, maybe you do on this one because it's not that hard. So let's write our work. How do I get B to D? Well, it's x plus 7. And x is 11 plus 7 is 18. Oh, what's cool in calculus, AP calculus, is you could leave it 11 plus 7 and get full credit. If you do 11 plus 7 and make it 19, you get the points taken back. Yeah. Yes. Yes, I want you to do it with a math sentence. Now, you can write your sentence backwards if you want. You could do 25 minus 7. You could even 7 times 2 equals x, but at least shows me what you're thinking. I got to be able to see your thinking. Many ways to do that. Things are going to get complicated, even today. Okay? Are we ready to go on to the next one? If it seems it's slow, if it seems it's fast, you must tell me. Okay, ready for that one? Looks complicated. I think you had some homework that was kind of similar to this last night. And all I have up are the answers. If you want me to work the problems and show you how I get to the answers, that's fair game. So I like to label everything. And I have a little bit dyslexic, so sometimes reading that all looks like X's and pluses to me. And I think, so I understand when it looks like that to you. So BC, that's this little guy right here, right? Because I can put them in the wrong place really easily. 3x minus 3. CD is 2x plus 4. Now, CD is congruent to AB. They have the same length. So how big is AB? 2x plus 4. So I'm labeling my diagram because it's now going to become crystal clear to me what to do. Now, be careful. It's AD is 33, but they could have given you AC. Different solution, different problem. But they didn't. They gave us A to D is 33. You can draw arrows, or you can just label it. It doesn't matter. I don't get that picky about it. Now it becomes clear to me what has to be true. I would call this the angle addition postulate, segment addition. But what if I add this plus that? I should get 33, right? Yeah. If you want me to really make it clear to you what I'm adding, I'll put in parentheses. They are unnecessary, but now I can really see what's happening. And if we have 6 lessons in this unit before we test, trust me, you are not going to remember what you did if you just have an answer. You're not. And then I want to combine similar terms. So I can't do this, by the way, any other way, not easily. I could take 33 and subtract all those little pieces. Oh, I didn't want to go there. Okay, let's add our similar terms. This is similar to this one, is similar to that one. What do those guys add up to? 2 plus 3 is 5, plus 2 is 7. Now, if you add it wrong, and you'll get, by the way, I think they're all nice answers. So if you get a decimal or fraction, you say, okay, I did something wrong. That's what I loved about algebra. And I guess I have some more similar terms. 4 take away 3, which is 1. plus 4 is 5. Yeah, 33. There we go. Now this is so much easier. And this is what we're doing in my quadratic algebra class. We're reviewing how to solve these equations. I undo the adding, subtracting first. If you need extra help, I'll see you Monday morning. So, and some of you may. That's nothing. What's 33 take away 5? 28. Now, if you want to get good at knowing number facts like I am, don't use a calculator. Not for things like that. And then what do? We divide by 7. Now, do I have to actually show the divided by 7? No. 7 times what is 28? 4. Good. That's all you're doing. Okay, now, AB, what's AB? Oh, AB is 2x plus 4. So I'm going to do this, 2x plus 4. So what am I going to put in for x? 4. Don't forget to answer the question. That's probably the biggest problem I ever saw in geometry was answering the question. Once we got over the vocabulary. So this is, can I do this in my head? 8 plus 4 is 12. I've been doing, why can I do this so fast? I've been doing it for a long time. Lots and lots of practice. BC is 3x minus 3. I put a placeholder here with my parentheses, and what's x? X was 4. Can you do that in your head? Right. Right? I'll let you use a calculator, but if you really want to get better with numbers and better number sense, do it by hand. Well, that's not too bad, is it? You see how we're going to use geometry, and we're going to use algebra to solve our geometry problems. I could do guess and check. It would take me forever. And I know good numbers to check. You guys don't have as good a number sense. Well, I have number sense because I've done a lot with numbers. Okay, so that's what I want to see for your problem. And when you come in and you don't have that, you say, I don't get this problem. That's the first thing I'm going to have you do. Okay. Let's label it. Maybe somebody wants to come up and do it. Same kind of problem. For an example 3. Okay, let's see. AB is 4x minus 2. BC, that's this little one in between. That's 3x plus 5. And these aren't that complicated. Compared to what we did in quadratic, they're not complicated. Be careful. AD is 3x plus 17. So read it carefully. Never assume. And by the way, when you look at your geometric figures, all you can assume is that when I look at this diagram, it is a straight line. It's clearly marked that AB and CD are the same lengths. So what has to be the length for CD? 4x minus 2. I can assume straight lines. I can assume that B is in between A and C. Those things are safe to assume. But when I draw a parallelogram, which I don't know if you remember, I can't assume anything about it. However, I will give you a hint. Draw it so it looks good, and what you think is true probably is true, but that's not proof. For the most part, you can't assume anything. Okay. What's the equation look like? Because I can't do it without it. I don't know about you, but I can't. Yeah. Plus equals 3x plus 17. Now, if you got that, you get the geometry. If you don't get what x is, which I don't know what it is, I don't remember, then you don't know the algebra. But it's clear to me when you say, okay, I got that, I don't know what to do. You know what to do next? How many x's are there? Well, I can see I've got, and if you use colors if you want. I have a 4 and 3, which gives me, any golfers here, you guys have to add these numbers up all the time. 4 plus 3 is 7. You're probably a little bit rusty. Plus 4 again, 11. So that's 11 x's. Now how about the numbers? And you're right, it might be faster for you just to punch them on a calculator. For me, that's not true. I can add these faster. A negative 2 plus 5 is 3. 3 minus 2 is 1. Equals 3x plus 17. All equations, linear equations, they're linear. The exponents are only 1. You always want to have no more than 2 terms on each side. You guys remember what terms are? Terms are a number you add together. These are terms. So we have to have a common vocabulary. If you're playing football, you better know what the coach is talking about when he talks about a lateral pass. I only know that because I know what lateral means. It comes from Latin. It means side. So it's not a forward pass. You can pass it backwards. But I think of it as a sideways pass. But whatever. For me to understand football, I better know what they're talking about. Still not sure what holding and clipping are, but I got an idea. Because I watch football. Yeah. Well, you have to go whatever your equation is. No. They could have said, so you have to look at your diagrams. They could have said that A to C was 3x plus 17. So read carefully. Then you would have this plus this is 3x plus 17. You want to add up whatever works geometrically. So I know that by this segment addition postulate, or what do they call it, overlapping segments, that this segment plus this one adds up to 3x plus 17. And you may assume that from your diagram. What you see is true. You just can't assume parallel lines, and you can't assume right angles and such. Did anybody solve that? What did you get for x? Everybody get 2? Good. How about CD? 6? And AD is 23? Okay, I'll trust you. A lot of people say that. What do you think engineers do? My best friend's an engineer. They don't have any answers. There are no answers when you build buildings. You work with partners, and you check, and you double check, and if you're wrong, somebody's life could be at stake. 35W bridge collapse, they didn't calculate the fact of the weight. They didn't think about into the future. That bridge was an old bridge. They didn't think about the weight in the year 2000. When was that? Well, 6 years ago. 2007. 35W was collapsed. It was 6 years. It was the year after my daughter died, and it was on her birthday. So I remember that very clearly. Her birthday was August 1st. And I was in Texas. Well, you were young. You get older, you remember a few more things. Okay, let's get this. I don't know why. Let's get this done. We have 3 more things to learn. Do you guys remember complementary angles? Now, this isn't really right. It's 2 angles whose sum is 90. Now, you can do this a couple ways. You could be given a diagram like this. Now, I know what sum. Whose measure? Sorry. Measure is 90. Because you can't talk about it. It's the measures that add up to 90. I know it's picky. I don't be that picky about it, but you still gotta be careful. You can't assume that those are right angles. Cannot assume those are 90 degrees unless I tell you or I put that little box there. Then you can do it. And you could put in a little line here like this. And I'm really lazy, like I said. I'm going to call this angle 1 and that angle 2. So that the measure of angle 1 plus the measure of angle 2 is 90. I'm going to get another equation. So instead of adding up segments, we're going to add up angles and practice our algebra a lot. Now, do they have to be connected like that? No. You could have angle 1 here, and you could have angle 2 over here. So if angle 1 is 35 degrees, how big would angle 2 be? Careful with the carry. 55. Very good. Okay, remember complementary. You're going to remember complementary means that the angles add up to 90. Their measures add up to 90. So I'll be honest with you. It doesn't always work that way. Now, what about this one? Supplementary angles. What's this called? And you know what? You're used to calling this a straight line, but we're going to call this a straight angle. What do you think about angles 1 and 2? What about those measures? They're supplementary. Do you remember what that means? Supplementary means they add up to 180. And again, they don't need to be connected. You could have an angle here of 30 degrees, and you could have an angle over here that's supplementary to that. And that would be how big? 150. Do you remember what this is called? This is kind of cute. Is it a cute angle? And this one is obtuse. Okay, these words coming back, this should be remember, not the first time you've ever seen it. Okay, isosceles triangles. Do you remember that? Iso means the same. That comes from the Greek. So two sides are the same. Do you remember what we call this triangle if all three sides are the same? Equilateral. Oh, we're only doing isosceles. So only two sides are the same. So let's go down here and see if you can draw this. They didn't ask a question. I will ask the question because it's begging the question. Draw a triangle ABC. I have two sides equal, so it's isosceles. That's good enough to write. The perimeter, what's perimeter? Distance around. I used to have horses. I used to have to walk the perimeter because if the fence were down, the horses would get out. And let me tell you, it's not fun catching horses. Anybody ever do it? When they get out, oh, you don't want to try to catch them because they run. The minute you get near them, you reach with their bridle, they run. They're really annoying. Until they're tired of the game, and then they let you catch them. Or you say, you know what? Just go out and be there. They come back because you feed them and you give them water. But in the meantime, they could get hit by a car or something. Okay. I have a triangle. I want to draw it. So I have a perimeter. It's 25 centimeters, and AB is 11 centimeters. They didn't ask me to do anything other than draw it. But I'm going to ask you to find all the sides because we can. Should we put AB here? And let's see. I better label that because I'm going to get in trouble. I tried this already today. I can't do it. That's AB. And now I want to draw AC and BC. So I'm going to put C someplace. Why don't we put it up here? It doesn't matter. Because we can never assume from our drawings, ever. So I could draw it really way off scale. Those are equal. And AB is 11, and the perimeter is 25, and they don't ask for the size, but why don't we find them? Because it's like, well, why do I tell me about the perimeter if they don't tell me that? What would you like to call this side? X. There you go. Give me an equation. And don't write it x plus x. 2x, right? I mean, you can. Plus 11 is 25. I'm good, fast at these. You know what else is nice about geometry? You're not going to have negative numbers. When did you see a square with negative numbers? You didn't. Okay, 25 minus 11 is 14. Nothing wrong with looking at that and saying x is equal to 7. And I think that's it. Following this is the homework. I want to just page through that. I think we're a little behind our schedule. What we don't get figured out today, we'll figure out also on Monday. We're going to go into the homework. Homework answers are posted, but not solutions. And maybe in particular you have a question for me. The patterns are very hard. It can be hard. Now, let's look at this one. This is looking for patterns. Here you're going to have to draw a picture. You guys pay attention so you know what you're looking at. You have an isosceles triangle. This is different. You've not done things like this. This one is so easy, you're going to say the answer can't be right. well, if I draw a parallelogram, they tell you what it is. You should know what it is anyway, but draw a nice parallelogram. Don't draw a rectangle because that's not what we're talking about. And there is what we did today. I fixed this on the smart board so these were lined up. Do not panic if you do not know all those words. There are some words in there that you don't know. You may know. Draw a picture. You should say draw a picture, set up an equation, and solve. So that's what the homework looks like. And here's my rule of thumb. Because you guys do have other classes, and you do have a life. At least I hope you do. And you do sports and things, and it is a Friday. But if you are focused on your homework and you're focused in class, the rule is no more than 30 minutes outside of class. Because if it's taking you more than that, that means you're not understanding and you're wasting your time, unless you want to spend some time trying to figure it out. So just come in and see me. But you should be able to get things done in a half hour, and you might not be able to. I don't know. Okay, so let's jump down here to the homework. So let's see if I can find how to get there. Okay. There shouldn't have been a big problem with 1 and 2. Answers are online. But there might have been some issues with some of these. Did you guys see the patterns? I didn't see the pattern on 4. My first hour told me what it was. Now, this is what geometry, to me, is about. It's about patterns. Recognizing them, using them. Obviously, 3 is not too bad. What are we doing on 3? You're adding 0, which is the same as multiplying by 10. Okay, so that was pretty easy, and the answers are online for that. But what about number 4? Did anybody figure out what's going on here? Yeah. Yeah. You're adding 1/6 each time. That gives you 2/6. Remember to add fractions and reduce it. We get 1/3. I want to go through these quickly, so I'm not going to do all the details. I tried to make it harder than it was. How about number 5? That wasn't too bad. How are you going from 1 to the next? -4. This next one, there's a couple ways to look at it. How did anybody do this one? Okay, +4. There's another way to do it, but that's good. I just want you to see the patterns, that's all. So if you don't have it down, write it down. Anybody recognize 7? Starts with an F. Fibonacci. Do you remember those guys? They're kind of fun numbers. You add these to get that one. You add 2 and 3 to get 5. So what's the next number? 8 plus 13 is? 8 plus 13 is 21. Then add these 2 and you get 34. Number 8. First hour, I really struggled with 8. Those are special numbers. What are they? They're squares. Why are they called square numbers? You guys got to ask some questions. Because if you draw a square with a side of 1 by 1, because we all know what squares are, what's the area? If you have a square that's 2 by 2, the area is? That's why they're called square numbers. But you never even thought about that. A lot of people don't. You're squaring them. How about the next one? Now, finding what they call the closed formula is trickier, but you can at least see patterns here. What's this doing? Going down by what? 2, down by 4. Okay. This is an 8th grade algebra standard. This is geometric. What is this doing? Multiplying by what? 2. That's exponential growth. And Lindsay, you might remember that from the end of last year. Oh, these were kind of fun. How did you do? Think about that one. Bring questions Monday because we did run out of time. Have a great weekend. What? Yeah. It's really cool, actually. I like patterns. I don't always see them.